Good morning, everyone, and welcome to our webinar on the global use of ARTISCAN example of CT QA with our expert today, Sylvain, our support and application manager.
Hello, everybody.
Please note that this session is recorded and remind you that you are in listen-only mode. You can raise a hand or send messages through the chat or the section, question section, of your panel at any time. And now we are switching our webcams so they can see a full screen. So before moving to the presentation, I'd like to give a short introduction of our company. AQUILAB is a French SME which develops and markets advanced software solutions to improve quality in cancer treatments. Our solution is divided into 4 activities. So first of all, we have the quality assurance of medical devices with our ARTISCAN solution, which is dedicated to imaging and machine QA. Then we help improve medical expertise with our RTV software, which is used for the preparation and evaluation of radiotherapy treatment. Another major activity is the quality in clinical studies to better evaluate new strategies. This is our web platform, SharePlace, that centralizes and analyzes imaging and radiotherapy data. And finally, AQUILAB is strongly involved in the training of radiotherapy professionals with online contouring tools. I'm sorry, I have lost track a bit. Let me refresh. With the online contouring tools dedicated to the organization of workshops. Sorry. And now I will give the presentation to Sylvain. And there you go for the webinar.
Yes, thank you, Florence. So first, I would like to start with a little introduction about our solution, ARTISCAN. So this software is a full independent machine QA software. It is all-in-one solution to ensure complete inventory of machines and QA tools and to define QA protocols and tolerances for each machine. It includes a full DICOM database, and all image analyses are fully automatic to ensure consistency of results. These results are saved in a centralized database that permits web access to all reports and trend analyses. The solution is designed to be adapted all equipment and all tests objects used in different organizations, and analyses are based on major international guidelines. Today, the solution permits automating machine QA in radiation oncology, but also in radiology and nuclear medicine. It permits to have a centralized solution to manage QA of the entire hospital. So let's show you now a demonstration with the software ARTISCAN. So here, this is the main window of the software ARTISCAN. As you can see, we have a set of DICOM images acquired for this example with the CAT 600 Phantom on a CT. So first of all, the user has to export the DICOM image with a DICOM push to the ARTISCAN server, and then the images are stored in the base. Once the protocol is created, the control is created, we have on the left here the name of the module, the CAT 600, and the list of parameters that we are able to compute. So once we are at this step, the aim is to have an automatic analysis. So for that, the parameters that the user wants to compute has to be assigned to the correct images to have a right analysis. So for that, we have in ARTISCAN what we call the analysis protocol. So if I load this one, so the protocol is specific to the device and the module. And once it's loaded, as you can see, parameters are associated to the correct images. So these both images for the signal to noise, for example, and the slice thickness, as you can see, the right images is associated. So at these steps, we just have to compute then all the parameters. And as you can see, the system is detecting automatically all the patterns that it needs to compute correctly all the parameters. So I let the system finish. I don't save the results right now. So as you can see, all the results will be displayed like that. We have on the left the DICOM image, on the right table with the different results, and a graphics if needed for the explanation. I can show you some example of parameters. So here we have the signal to noise ratio. On the DICOM image, we trace automatically 6 regions of interest, as you can see here. And from each of them, we extract the signal to noise ratio. Maybe another one, the slice thickness. So for the slice thickness, the system first detects the 4 ramps of the phantom, and then on each of them, it traces a profile to, as you can see, the different profiles, and we then extract the 50% of the maximum to obtain the slice thickness in millimeter. Maybe a last one with the high contrast resolution. So here we detect each pattern that represents a line pair per centimeter number. And from that, we trace a profile on each of them to then obtain the transfer modulation function. So you see this function on the graphic. And from this function, we are able to extract the resolution in line pair per centimeter. Maybe you've seen just before, if I take the signal to noise, for example, that there is a color code, as you can see here. In fact, the user can define his own tolerances, and these tolerances are defined in the protocol. So for example, if I show you for the slice thickness, as you can see here, we just have to define a reference value and then until 2 levels of reference in absolute or in relative to the reference value. And so once all the results are computed, the next step is to save the results. And when we save the results, automatically a report is generated and some points are added to the different trend curves. And then all this data, the report, the trend curve, are available from a web browser. So here, as you can see, I have first selected the right device, the GE and the protocol 45600. And I have in this page an overview of all the control of this year. And for each of them, I can see the date of the saving of the results, who saves the results, the number of results in, on, or out of my tolerances, and I can see if the report has been approved, as you can see on the right. And then if I click on the consult button, I can go directly on the report. So this is the report. In the DICOM header, we have information about the device, information about the control, so the date of the acquisition of the image, who saved the results and when. And then for each group of parameters, we have some tables with the different results. As you can see, we can let some comments for each of the tables. And we have the color code that represents the user tolerances. And if I go down, we can approve this report. So if I click on approve and then confirm, as you can see, the report, if I go then on the top, we have this check to display that it is right approved. So this report can be exported in PDF format. And the last thing that I want to show you is the train curve. As you can see here, with this device and protocol, we have access to the train curve. In blue, we have the reference value, and then in the curve, the different points of the different controls. Some statistics are automatically computed, as you can see, and this can be print or export in a datasheet format. So that was a quick overview of the use of ARTISCAN with the example of the city with the module 45600.
Okay, thank you, Sylvain. So we get back with our webcams, and I will share my screen again. There we go. And we had a question from one of the attendees that is, how do you store the data? Is there a database?
Yeah, in fact, there are two databases, one SQL database and one files database, and we store everything. I mean, the DICOM images, the report, all the results, the analysis protocol with the tolerances, everything is stored in the base. And to be complete, this base can be installed on virtual machine, for example. And this is a client server system with floating and fixed license.
Okay, thank you, Sylvain. Well, that's it for this webinar. Thank you for attending, and do not hesitate to contact us for more information on our solution, and have a nice day. Bye.
Thank you. Bye.